This is Algebra 2 with trig. We're talking about Chapter 13, 13.1. This is notes for Day 2 on 13.1. We're going to start with discussing what solving a right triangle means. You learned this in geometry, but it's important to understand what the terminology means when it says solve a right triangle. You need to calculate for the missing sides and angles. Remember that when finding sides, we use our trigonometric ratios. That's what we did in our previous lesson. When finding the angles, we use inverse of our trig ratios. That's second inverse. And with your calculator, you want to be sure that it's in degree mode. So with your graphing calculator, you need to go to mode, which is above the 7, up near the top, and then down 3 rows to figure out radian or degree. So with our graphing calculator, here's mode. It's above the 7 near the top. You would need to scroll down. Radian is one version. We'll learn about that some more later. And degree. You would hit enter to make it stay on degree. So we're going to solve triangle ABC. Notice that the format of all of our triangles are going to use C as our right angle. So if C is 20, I'm going to draw a separate triangle over here. If C is our right angle for this, it's not always true, but it is for all of these 3 questions. Side C is going to be the hypotenuse. Angle A and angle B angle A is supposed to be 54 degrees, so I made A my larger of the 2 angles. Side A is going to be opposite that. Side B is going to be opposite angle B. So now we have to calculate what our missing sides are and missing angles. So to find the measurement of angle B, we could say that the acute angles of a right triangle are complementary. So 90 minus 54 gives us 36. So that's the measurement of angle B. Now I know all 3 angles, 36, 54, and 90. Always remember the acute angles of a right triangle are complementary. They add up to 90. Using the idea of SOHCAHTOA, that helps remind us what the trig functions are, I can now find an opposite side to angle A by using sine, opposite over hypotenuse. Hypotenuse is always across from the 90. So sine of 54 is going to equal the opposite side over the hypotenuse, which is 20. Put your trig over 1, cross multiply, so we get 20 times the sine of 54, which equals A. And then using your calculator, you can figure out that that is 16.18. So now we know two sides. We know side C and side A. We now have to find side B. Notice that side B is next to the 54. It's a leg, and it's next to it, so it's called the adjacent side. So we're going to use the adjacent and the hypotenuse, which is cosine. Cosine of 54 equals the adjacent over the hypotenuse. Cross multiply, and we get 20 times the cosine of 54 equals B. And with our graphing calculator, we should be getting 11.76. So those are the three sides, 16.18, 11.76, and 20, and the three angles, 36, 54, and 90. Let's try that again. Angle A in this case is 32. Side B is called 10. We have to find out the other angle in the other two sides. Recall that the acute angles of a right triangle are always complementary. So 32 and what makes 90? So we subtract the 32 to get 58 degrees, and that gives us the measurement of angle B. Now if we want to find out the hypotenuse, B, the length of 10, is next to, so it's the adjacent, and of course across from the 90 degrees is the hypotenuse, so adjacent over hypotenuse is cosine. So cosine of 32 degrees equals the adjacent over the hypotenuse. Notice that the variable is on the bottom of the fraction, in the denominator. We place our trigonometry over 1, cross multiply, so C times the cosine of 32 equals 1 times 10, which is 10. Now this is where a lot of people make a mistake. They multiply, because we multiplied earlier, they multiply cosine of 32 with 10. But think about your algebra. You have to divide by the cosine of 32 to get C by itself. So that gives us a value of 11.79. So now we have all three angles and two of the sides. What's the side that we're now missing? Side A. So to find side A is across from 32. Side A is the opposite side. So we're going to use opposite and adjacent. I suggest to use the numbers that they give you. Don't use a calculated value if you can help it, because that helps you be sure that you're not making a mistake now if you made a mistake earlier, or use rounded numbers. So opposite over adjacent is tangent. So tangent of 32 equals opposite over the adjacent. Cross multiply, 10 times the tangent of 32 equals the A, and side A is going to be 6.25. So now we know all three sides and all three angles. So we can take this triangle. You should pause the video, try it on your own, log back on, and see how you did. We would make our right triangle. Remember we talked about C. This is very important. C is the right angle. It doesn't matter what the other two would be. It looks like this one might be smaller, so let's call it the 19. This one looks a little bit bigger, so let's call it the other angle. So now we need to find angle A. We know what side C is, and we need to find side A and side B. Remember that side A is always across from A, and side B is always across from B. So 90 minus 19 gives us 71, and that's the measurement of angle A. To find A, which is the A is the adjacent side to the 19. It's the adjacent side. The 20, side C, is the hypotenuse. So again, we're going to use cosine of 19 to be adjacent over hypotenuse. Cross multiply. 20 times the cosine of 19 equals A. And using your calculator, you'll get 18.91. Now, for us to find our missing side of B, that is opposite the 19. So that's the opposite side, and we're going to use the hypotenuse. So sine of 19 equals opposite over the hypotenuse. Cross multiply. Using our calculator, 6.51 equals B. So we know all three sides, and now we know all three angles also. For example number 5, you're hiking towards the main road, but reach a point where the road is flooded. So here's our original road. We're hiking towards the main road. We reach this flooded area. Big flood there. So we're going to take a 48-degree turn. 90 would be straight across. So that's why it's called a 48-degree. It would be small. And we're going to walk at a diagonal. The diagonal is a total of 3.6 miles. How far were you from the main road when you turned onto the diagonal road? So we're trying to figure out how long X is from about there down to the main road. Well, this is a right triangle. We have an angle of 48 degrees. The side next to it, the leg next to it, would be called the adjacent side. Across from the 90 would be called the hypotenuse. So using SOHCAHTOA, we know that cosine would be adjacent over hypotenuse. So cosine of 48 equals the adjacent side over the hypotenuse. Put it over 1, cross multiply, 3.6 times the cosine of 48 equals our X value. When we multiply those two together, we get 2.41, and that's our X, and that would be in miles. On the flip side, we're looking here at the diagram. It's just giving us some notes on what is the angle of elevation compared to the angle of depression. If you look up at an object, so if we look at the top of the building, angle of elevation is your angle line of sight that's done with the horizontal. So looking up compared to the horizontal, that would be your angle of elevation. Now if you were on top of the building, looking straight out, your angle of depression would be the angle at which you look down. Now, a common mistake is for people to think that the angle of depression is the other acute angle of the right triangle, and that's not true. Actually, the angle of depression and the angle of elevation are the same to each other. This is a zigzag, so they're alternate interior angles. So they're the same measurement. The horizontal land should be parallel to the horizontal horizon. One thing you need to remember, that you're always comparing this with the horizontal line. So your angle of elevation is off the horizontal, that's the angle that's formed, and your angle of depression is off the horizontal. So always remember the elevations of elevation and depression are measures from the horizontal line. The angle has to touch the horizontal line. So from a point on the ground, 28 feet from the base of a flagpole. So we'll put a little ball up on top of a flagpole. Put a flag there. So there's our flag. We have from the base of the flagpole 28 feet. The flagpole would be standing straight up at 90 degrees. We would have a right triangle that's formed. The angle of elevation is 63. And we want to find to the nearest foot what the height of the flagpole is. So looking across from the 63 is our opposite side. Next to the other leg next to the 63 is called the adjacent side. So SOHCAHTOA tells us that we're going to use tangent of 63 equals the opposite over the adjacent. So we'll take that, we'll put it over 1, we'll cross multiply. So that gives us 28 times the tangent of 63. That equals x, which using our calculator is 54.95. So rounded to the nearest foot, we would be at 55 feet. Next, we're going to take a parasailer, and it's attached to a boat with the rope that's 300 feet long. So we're going to take a boat, put a motor on the back of that boat. We'll hook a little platform up and put your 300-foot line off the back. Connect your parasailer, which you're just hanging there, and make a right triangle out of that. We know that the parasailer, the angle of elevation from the boat to the parasailer is 38 degrees. We know that the rope is 300 feet long. To the nearest foot, how high is the parasailer? Well, we're trying to figure out that value. So we're going to look across from the 38, which is opposite, across from the 90, which is the hypotenuse. So SOHCAHTOA tells us that it's opposite over a hypotenuse. So sine of 38 equals opposite over hypotenuse. Put it over 1, cross multiply, 300 times the sine of 38 equals x. When we use our calculator, we get 184.70. You always want to write the exact value down. And then it says to round it to the nearest foot. Well, that's closest to 185 feet. Last question. From a point on the ground, 64 feet from the base of a tree, there's our tree. From the base of the tree, we're 64 feet. The angle of elevation to the top is 28. To the nearest foot, what is the height? So again, we're going to use opposite. Your right angle would be that the tree is standing up perpendicular to the ground. So your hypotenuse is on this side, the adjacent side is the other leg that makes the angle. So we're using opposite and adjacent. Opposite and adjacent gives us tangent of 28 is x over 64. Put that over 1, cross multiply. When we calculate that, we get 3403. And to the nearest foot would be 34 feet. That's how tall our tree is. I want to show you an additional example of us finding the measure of an angle. Here would be a situation where we're given a right triangle. We have a right angle. Across from the right angle is the hypotenuse. If we're looking for the measure of angle A, across from theta, or our angle, is the opposite side. Next to it is considered our adjacent. So we know that we're going to use, thinking of SOHCAHTOA, that the opposite and adjacent would be tangent. So just like before, tangent of theta, you could say, or tangent of A, whichever way you like to write it. Tangent of theta equals the opposite over the adjacent. So we know that tangent is supposed to give us this ratio of 3/4. Well, there's only one angle that could possibly give you an opposite over adjacent that is 3/4. Or you could call that 0.75, because you would have the same angle if it was 6 over 8. It has to be a reduced fraction down to 3/4. But regardless of the measurements, 5 and a 7, a 2 and a 1, whatever the measurements were, you would always say, set up your trig function the same way. We want to get the angle by itself. So we are going to move the tangent to the other side. So to do that, we are going to say the angle equals tangent inverse of 3 divided by 4. You learned this in geometry class. So we'll bring over our calculator. Be sure you're in degree mode. So we'll say second, have to hit the second button, tangent, 3 divided by 4. If you're doing a fraction, it has to be in parentheses. Most of the graphing calculators put that in automatically. So we know that we're going to be 38.87 degrees, 36.87 degrees. The measure of angle A equals 36.87 degrees. Let's try another one. So if we know we have a length of 5 and a length of 13, we're looking for the measure of angle A. So that's our theta. So across from theta is always the opposite side. Next to it is always the adjacent side. Across from the 90 is the hypotenuse. So using SOHCAHTOA, we know that we would use cosine of angle A equals the adjacent over the hypotenuse. To get the measure of angle A by itself, we're going to do the inverse. The inverse moves cosine away, so now we have the measure of angle A, got A by itself, to be cosine inverse of 5 divided by 13. We take our calculator. Be sure you're in degree mode. Cosine inverse, you got to be sure it says -1. 5 divided by 13. That gives us 67.38. So the measurement of angle A equals 67.38 degrees. If you know two sides of your right triangle, you can calculate the angle by doing the inverse. I'll do a last example. If you have a right triangle and we have some side lengths of 9 and 15, we're looking for the measure of angle A. We know across from our A is our opposite side. Across from the 90 is the hypotenuse. So SOHCAHTOA reminds us that we're looking at the opposite in the hypotenuse, which would be sine. So sine of our theta equals the opposite over the hypotenuse. So here we don't know what the angle is, so there's nothing to type into the calculator. No reason to cross multiply. We don't know what the angle is. So to get the angle by itself, which happens to be angle A, we're going to use the measure of angle A, because that's where theta is located, equals sine inverse, because that moves the sine to the other side, of 9 divided by 15. So second sine, just got to say sine -1, which is sine inverse, of 9 divided by 15 gives us our 38, I did it again, 36.87. You might recognize that that matched another example we had above. It's because the triangle I had above was a Pythagorean triple of 3, 4, and the missing side must have been a 5. And down here, I have 9, something, and 15. Well, 9 and 15 are multiples of 3. 3 times 3 is 9, 3 times 5 is 15. So this is truly a 3, 4, 5 triangle. So it's the same type of triangle, and I was looking for the side opposite the 3. It happened to be the same measurement. The triangles are not congruent, but they are similar to each other. Therefore, the angles are congruent and the sides are proportional. These are inverse trig functions.